practice exam 2, problem number 4. Right? So we want to find the absolute maximum and the absolute minimum of this function over this closed interval. Right? So let's do that. Right, since this is over a closed interval, we can just look at the endpoints and the critical numbers that are included in this interval. Right, so let's do that. Alright, so let's take the derivative. So f prime of x is equal to, alright, so you have two things multiplied together. So again, we're going to have to use a product rule here. Right, so derivative of the first guy is 1 times the second guy, which is a quantity x plus 1 squared, right? Then plus, right? First guy is quantity x minus 2 multiplied by derivative of the second guy, which is 2 times quantity x plus 1, right? And subtract 1 from the power, it's 1, multiplied by derivative inside, which is 1. So I'm not going to write anything else down. Right, then derivative of 3 is 0, so it goes away. Right, then we need to simplify a little bit. So what's in common is, let's see, you have x plus 1 here. We have actually two of them, so I'll just circle that. So you see that quantity x plus 1 can be factored out. Then we combine everything else. So you have x plus 1 from the first term. Right here you have 2x minus 4 is there too. Right? Then we can just clean that up. So you have a quantity x plus 1, and this is 3x minus 3. Right? So luckily these guys have 3 in common, so I'll pull 3 out as well. So you have quantity x plus 1, and 3 is factored out, so you have x minus 1. Right? So if you set this guy equal to 0, then we can find the critical number, which is x is equal to negative 1 and a positive 1. So those are the critical numbers. Right? But you can see that the interval is from negative 3 to 0. So even though 1 is a critical number, but we're not going to consider that because it's outside of the interval. So we only look at the critical number negative 1. Alright, so next thing you need to do is just evaluate the function at the endpoints and the critical number. Right, so we have f of smallest one is negative 3. Right. Next one would be f of negative 1, and then you have f of 0. Right? So negative 3 is the left endpoint, negative 1 is a critical number, and the 0 is the right endpoint of the interval. Right? Let's compute that. Right? So if you plug in negative 3 into the original function, so you will get, let's see, negative 3 minus 2, so it's negative 5, right, times, right, negative 3 plus 1, so it's negative 2 squared would be 4, right, then plus 3, right, that will be negative 20 plus 3, so negative 17, right. So if you plug in negative 1, this one's actually easy, because if you plug in negative 1 here, it's 0. So that whole thing is 0 except for that 3 at the end. So can I just say that's 3? Alright, if it's 0, so it's a 0 minus 2 is negative 2 times 0 times plus 1 is 0, square would be 1. Then you add 3 to that. Right, so it's a negative 2 plus 3, so that's 1. Alright. So you can see that the largest value is 3, so this is the absolute maximum, right? So this is the absolute maximum since it gives you the largest value, right? Absolute minimum is obviously negative 17, so this guy is the absolute minimum. So we have that. Right? Right, so if you're looking for a maximum and minimum over a closed interval, you just have to look for critical numbers and endpoints, and whichever gives you the largest value is the absolute maximum. Whichever gives you the smallest value, that will be the absolute minimum. Right? That's it. I hope that this was clear.